Okay guys, so first part of these videos we're going to talk about exponential functions and their graphs and things like that. So exponential functions are the ones that are like y equals 2 to the x, y equals 3 to the x. Anything where x is actually the power, and it's not to be confused with x squared and things like that, because we know that that gives us a parabola, while x to the third gives us a cubic function, and so on and so forth. So let's graph y equals 2x, 2 to the x, with a t-table. So we have x values, we have y values, let's do a couple negative, -2, -1, 0, 1, and 2. We're going to graph these. So let's look at these real quick. We have y to the negative, we have y. Let's do the 1 first. Y equals 2 to the 1. Well, you know that that's 2 to the first power, which is 2. We have y to the second, which is 4. What about y to the 0? Well, if you think about it, let's explain why y to the 0 is actually equal to 1 and not 0, because some people confuse that. If you have y is equal to 2 to the second over 2 to the second, you know that you have y is equal to 4 over 4, which you know 4 divided by 4 is 1. Well, if you agree that this is equal to this, then why would it not be the case that 2 to the 2 minus 2 is equal to 2 to the 0? And if you know that this is equal to that, which is technically this, then you can kind of go back and say, oh, then that equals that, and that must equal 1. Okay, you just basically follow the chain backwards to get to the conclusion that 2 to the 0 must be 1. Now, if you have 2 to the -1, well, we said that this is 2 to the -2 because that's what that represents. So this must be 1 over 2 to the 1, which is 1/2. And then 1 over 2 to the second is going to be 1/4. Okay, so we get all these nice points and we can graph this. So we've got -1, 1/2. So here's -1, here's 1, here's -1/2. We have -2 and 1/4. That's probably right there. We have 0 and 1, and we have 1 and 2, and 2 and 4. And our graph does something kind of like this. Okay. Now, there is an asymptote. What you'll realize is that if you do 2 to a really big negative number, 2 to the -1 millionth or something like that, then what happens is this becomes a very small this becomes 1 divided by a very small number, and it never actually reaches 0 because you're taking 1 and you're cutting it into very, very, very tiny pieces, and it will just only get close to 0, closer and closer as you make the pieces smaller and smaller, but it will never actually equal 0 because you're always dividing 1 by something. And so there turns out to be an asymptote on the line y is equal to 0 in this case. Now, of course, that changes based on shifts. So if you remember transformations, if I gave you the following, y equals 2 to the x plus 1, then this 1 is going to shift all of these values that were approaching 0 up 1, and now they'll be approaching 1 rather than 0. So what I mean is, if you draw a line here, all of these same points are just going to be graphed up a little bit higher than they were on the other one. Okay, remember, this is y equals 2 to the x. This is y equals 2 to the x plus 1. Okay, so keep that in mind. So that's taken care of. Let's see, what else do we have? I would have you guys graph these if we were in class, but obviously we're not. Let's do y equals 1/2 to the x. So if I do another t-table, x, y, -2, -1, 0, 1, and 2. So if I do 1/2 to the negative 2, that's going to be, flip this over, this is going to be 2 to the 2, which is 4. Same rules apply, negative 1 over 2, sorry, not negative, to the negative 1 is going to be 2 to the 1, 2, 1, because that's the 0, anything with a 0 is 1. 1 would be 1/2, and 2 would be 1/4. So you kind of see we have the same stuff going on, but it's just backwards this time. So if I go ahead and graph this, then we have 1/2, 1/4, 1, 2 somewhere up here, and 4 is somewhere up even higher, so something like this. So all it did is take our other graph and basically rotate it around. Now when it gets closer to positive infinity, it'll approach 0 but never get there. You can see that it's getting smaller and smaller, going the higher the positive numbers go. So that's taken care of. What about if we have, this should have been changed. This should say, no, that's good actually. Y equals 2 to the negative x. Let's try that. X, y, negative 1, no, sorry, negative 2, negative 1, 0, 1, and 2. So if I plug negative 2 in, I have 2 to the negative 2, which is 2 to the 4, 2 to the 2, which is 4. 2 to the negative 1 is going to be 2 to the 1, which is 2. And then we have 2 to the negative 0, which is 1. It's always 1 because 0 will give us 1 every time for the power. And then we go again. Sorry, this shouldn't be down here. Get rid of that. And then if I do 1, 2 to the negative 1, it's 1/2. And then 2 to the negative 2 is going to be 1/4. And you see we got exactly the same numbers. And so we can say 2 to the y equals 2 to the negative x is actually the exact same thing as 1/2 to the x. Now why is that? Because if I wanted to rewrite this, I could rewrite this as 2 to the negative 1 to the x. And then the power rules tell me that if I raise a power to a power, I have 2 to the negative x. So we can see that that happens. If we wanted to do domain of these, there's obviously no value for x that I cannot choose because I will never be dividing by 0. So that's negative infinity to infinity. And the range, if it's for the function y equals 2 to the x, or 3 to the x, or anything to the x, is basically going to always be 0 to infinity unless it's flipped upside down. To flip it upside down, then you'd have to put like a negative in front of it. Okay. Then it would change it to negative infinity up to 0. Or it's shifted. So if I add the 1, that's obviously the range. Let me do another. I'll do another domain and range. And let me do y equals 2 to the x plus 4. So the domain of this is still going to be negative infinity to infinity. But the range now has changed from, not 0, sorry. So it's originally 0 if it's just 2 to the x, but we're adding 4 to that, so 4 to infinity. If I do y equals 2 to negative 2 to the x minus 3, okay, then our domain, negative infinity to infinity, that's ugly, sorry. And the range will be from negative infinity up until negative 3. How did I know that? Because it's negative now, so it's flipped upside down, so it's shaped like this. And it comes up to negative 3. So I hope this helps, guys. If you have an inverse function, remember that it will switch the domain and range, and we will talk about logarithms next, and that is why I'm bringing that up. Thank you.